Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In this video we are going to put together the last parts of functionality for configuring texture import settings. We can continue where we left last time, and to recap, we are now able to define a group of image files from which we can create a texture that contains one or more images. This is useful when we would like to create a cube map, for example. We are also able to reorder the image files or remove them from the list. Now, in order to specify what kind of texture we would like to create, we need to add the last piece of the user interface where we can configure various settings. This is similar to what we made for geometry assets, except it has a few more configuration options. So, like before, we'll create a new user control that contains the settings and replace the placeholder here with this new user control, which we call Texture Import Settings View. As always, fix the namespace first. I'll add the design time data context, which is texture import settings. This way it recognizes the properties to which we bind, making sure that we don't make typos. And I'll give it a gray background. We can make two columns for setting names and values respectively. And looks like we'll need 5 or 6 rows. I'm not sure how many settings we exactly have, but let's go with 5 for now. First, I'll add the names of all settings. Like I said, these will be displayed in the first column. I'll add a local style for text blocks to user-controlled resources so that we get a light font color and proper alignment. Next, we can add the UI control for each setting. I'll use radio buttons to choose the texture dimension. A wrap panel is used to group the radio buttons together. Alternatively, we could have used a combo box with a drop-down menu from which we could select a texture dimension, but I think this looks better. Since each radio button's either checked or unchecked, we need to add a converter class in order to convert each texture dimension to a Boolean value. We can do this by checking if the value of the property to which the radio button is bound is the same as the index of the radio button, which will pass as the converter parameter. In order to convert back, we can simply cast the index to texture dimension enumeration type if the index is valid. Otherwise, we default to texture 2D. I'll add the converter in the user-controlled resources so that we can use it for the radio buttons. Now I can make a radio button for each texture dimension. The font color isn't correct here, as you can see. I'll define a global style for most of these controls in a later blue episode. However, for now I'll just set the foreground color. The next setting is the number of MIP levels we want to have for the texture. Setting it to 0 will generate all MIP levels down to a 1x1 pixel image. Otherwise, it will generate the given MIP levels as long as the texture is large enough to have that many MIP levels. We use a slider for this setting. Next one is a checkbox for using block compression. If this checkbox is checked, a combo box will be displayed from which we can pick the BC format that we'd like to use for encoding the texture. I'll set a few design time properties so that we have examples to look at whenever we are going to restyle these controls. When we want to use a block compression format, we can let the importer pick the best format for the image or images that we are trying to import. We made our importer smart enough to know when an image is likely to be a normal map or when it should use a BC1 format instead of BC3. If you're not sure what these formats are, I made a video that explains them in detail, which you can feel free to watch. Whenever the importer chooses BC3 or BC1, we can tell it to use a higher quality BC7 encoding instead. That's what this extra checkbox is for, which only appears when we want to compress and we want to let the importer pick the best format by not explicitly providing a BC format. If we are not using block compression, the texture will be imported in whatever format the source image has, or a format that best fits the source. In that case, we'll use a text block to display the format. Note that this is not known before importing the image and therefore is displayed as DXGI format unknown. We can use a converter to get the description of the enumeration. We wrote this converter in one of the previous episodes. It returns the text in the description attribute that we provide with each enumeration. And here you can see the converter code. In case that we do want to use block compression, a combo box will be displayed on top of the text block and will let us choose a BC format. In order to set the items in the combo box, I'm going to use an object data provider, which is part of WPF. We can use it to call a method from a class and it will give us the return value of that method. In our case, we call getValues static method of the enum class. Enum class is part of the system namespace, which I need to add before we can use it. We passed the BC format enumeration as the method parameter, which will return an array of all enumeration items within BC format. We can bind this array to the item source of the combo box and use the enum description converter in order to get the user-friendly name for each item. We also bind the selected index to format index so that the importer knows which format we would like to use. As I mentioned, this combo box is only visible if the user wants to use block compression. We can use the boolean to visibility converter to determine its visibility. This converter also comes with WPF. The last setting is the alpha threshold. However, this setting is only relevant if we want to encode an image using BC1 format. Therefore, I'll use a trigger which will display the setting only if compress is true and the format index is 1, which corresponds to BC1 format. To set the value of the alpha threshold, I'll again use a slider with a value that can change between 0 and 1. Now we can go back to the configurator panel and use our texture import settings view instead of the placeholder. Don't forget to bind its data context to import settings property of the view model. Now I am excited to announce that the import settings configurator for textures is hereby complete, and we have now the ability to create any kind of texture that is supported by the 3D12 and probably also by other graphics APIs. Here we can see that we are able to select any BC format that we want. We can also see the alpha threshold setting when we select BC1. I'm not sure why the slider is not looking right though. Let me see if it's an alignment issue. Oh wait, I set the wrong properties. These should be minimum and maximum. Not sure what happened there. Okay, now it's displayed correctly. We can also choose not to use block compression, which will hide the settings controls that have to do with block compression. Okay, let me create a new folder for our texture tests and create a 2D texture array. I'll let the importer pick the best BC format. Here we see that it created a 2D texture array using BC1 format, which is indeed the best format for textures that don't have any transparency. Of course, we could override this by setting prefer BC7, which would then pick BC7 instead of BC1 or BC3. Here we can view each texture within the array. I'll rename this to texture2D array. I'm also happy to see how flawlessly everything works together here. No stutters and delays, as it should be. Let's create a 3D texture next. This time it failed while it shouldn't have, so there is a bug that we need to fix. I have no idea what exactly is the cause of this problem, so I'm just going to set a breakpoint in the import function in the C++ code and work up from there. I'll use the same set of images to create a 3D texture. I'll set a few more breakpoints at places where I'd like to inspect the data. They'll also hit if there is a size or format mismatch in source images. This doesn't seem to be the case though, so I suspect that's somewhere in the C# code. That's where I set the next breakpoint. I'll set one right after we return from the import function. Here we see that the array of slices is null, which means that we already failed in the import function. Okay, then let's have a look at the boundary where we are exchanging data between C++ and C#. This is our API wrapper method in which the actual C++ import function is called. I'll set a breakpoint at the end of the C++ import function and check if the data is packed correctly. So this looks plausible. I don't see anything out of place here. Going back to C# side, it still looks fine. There are no import errors either. As you can see here, the information that's returned looks absolutely fine. So the last methods to check before we return are the getSlices and getIcon methods. Let's see what happens in getSlices. Oh, nothing much happens here actually. It allocates some memory and copies the data, which should be fine. But then it calls slicesFromBinary method, where we can look next. Here we see that it knows that we have created a 3D texture, which is promising. And then we have a triple for loop, which are skipped when I try to run them. So that's where the problem is. Okay, we pinpointed the problem area, which is within these for loops. And after staring at it for a while, I can see I used a wrong index here. I used I instead of J. Let me quickly make sure that I didn't make the same typo anywhere else. Which doesn't look like I did. So let's try again. And this time it did create the texture successfully. Opening the texture, we can see it's indeed a 3D texture, also encoded using BC1, and we can scroll through its depth slices. These are the same as the source images for the first MIP level. However, if we select a different MIP level, we can see that each slice is a blend between two or more images. This is in contrast to texture arrays, where each MIP level is a half-sized copy of the source image. Okay, that's great. Let me fix a few typos here. And here in geometry from scene data, I'd like to turn this assertion into an actual error that's also handled in release build. So an exception is thrown if the data is null or data size equals 0. And that's all I wanted to do today. We are pretty much done with everything related to import settings. Next time we'll have a shorter video about re-importing textures using different import settings than the ones used to import them. After that, we can send the textures to our game engine and use them for rendering. As always, thank you for joining me and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!